of Falcon 9, our two-stage liquid-fueled rocket. It's 70 meters tall, greater than the wingspan of a 747 aircraft. We are flying today's booster for a sixth time. This rocket first flew on a GPS-3 Space Vehicle 3 mission in November of last year, followed by two Starlink missions. In 2021, it supported the Turksat 5A mission in January and another Starlink mission in February. On two-thirds of the vehicle is the first stage. You can see the tip markings left over from its previous 5 flights. The first stage's job is to accelerate the vehicle through the Earth's atmosphere in space with the help of 9 Merlin engines at the base of the rocket. And as I mentioned earlier, we are going to be attempting to recover the first stage on the drone ship that you see on screen right now. The drone ship is named, of course, as the Lovely, and if we are successful today, this first stage will be returning for the sixth time. And on top of the first stage is the black carbon fiber inner stage, and then on top of that is the Falcon 9 second stage, which has a single Merlin vacuum or MVAC engine. Once the first and second stages separate about 2.5 minutes into the mission, the MVAC engine will ignite and carry the Starlink satellites into their elliptical orbit around Earth. And at the top of the rocket, notice the large nose cone. That's where the extracted Starlink satellites are safely enclosed. The cone protects the satellites from aerothermal heating, aerodynamic loads, and contamination during ascent. Once we reach the vacuum of space, we will jettison the fairing halves as the second stage continues its journey into orbit. It will be the second flight for today's fairing, and we're going to be attempting to recover each half again in what we refer to as a wet recovery, which just means that we'll be retrieving each from the water. Falcon 9 has been loading propellant since the T-minus 35 minute mark. We use a rocket-grade kerosene known as RP1 for our fuel, and super chill liquid oxygen or LOX as our oxidizer to power Falcon 9. Currently, RP1 and LOX are nearly fully loaded on both stages, and LOX will continue to be topped off right until the final minutes of the countdown. The latest weather report is 90% favorable for liftoff, and weather conditions also look good for booster recovery as well. With that, the vehicle, satellites, weather, and range are all looking good for an on-time liftoff just a few minutes from now. If for some reason we don't launch today, we do have a backup opportunity tomorrow at 4 a.m. Eastern. And for those that have been following SpaceX, you know that it's been an exciting time for the development of our Starship launch system. Our Starship spacecraft and Super Heavy rocket, collectively referred to as Starship, are designed to be a fully reusable transportation system that can carry both crew and cargo to Earth orbit, the Moon, Mars, and beyond. On March 3rd, Starship test vehicle known as Zero Number 10 completed SpaceX's third high-altitude flight test of a Starship prototype from Starbase in Texas. Similar to the high-altitude flight test of Starship Zero Number 8 and 9, Zero Number 10 successfully reached its apogee at 10 kilometers with the help of 3 Raptor engines. It then performed a propellant transition to the internal header tanks which hold the landing propellant before reorienting itself for re-entry and a controlled aerodynamic descent. The Raptor engines reignited as the vehicle performed the landing flip maneuver immediately before successfully touching down and landing on its pad. Most of the testing at our Starbase Texas location has been focused on the spacecraft, but the team just finished the first Super Heavy booster that you see on screen right now. Known as Booster 1, this vehicle is a production pathfinder. We'll use it to figure out how to build and transport a 70-meter tall stage. All in all, it's been a great couple of weeks for the Starship teams. These test flights and pathfinders are all about developing a transportation system that can help humanity return to the Moon, travel to Mars, and beyond. We are anticipating Zero Number 11 to take flight in the days ahead, so be sure to check our social media accounts for updates. We are just under 5 minutes from liftoff, and Falcon 9 is now moving into the final stages of the countdown. We're currently waiting
for the transporter erector, or TE, to retract away from Falcon 9. That is the white painted structure right next to the vehicle. First, the TE clamp arms will open up, and then the transporter erector will begin to retract away from the rocket slightly. You just heard the call that we are beginning that process. At T0, the hydraulics will pull the TE farther away from Falcon 9 as it lifts off. The transporter erector has a couple of jobs. It provides liquids, gases, electrical connections to the second stage, as well as air conditioning to the payload fairing. And you can see that the clamp arms are now open at the top of the vehicle, and we should see the transporter erector begin to retract away to its pre-launch position from Falcon 9. The first and second stages are both nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Super chill liquid oxygen is our propellant oxidizer. That is what's creating those white clouds that you see around Falcon 9, and that's because the warm, humid, ambient air causes the liquid oxygen to turn into gas. First stage should finish prop loading around the T-3 minute mark, and the second stage should finish about a minute later around the T-2 minute mark. At T-60 seconds, Falcon 9 is in startup. This means that the rocket's autonomous internal flight computers have taken over the launch countdown, and just inside of the T-2 second mark, we light the Merlin 1D engines and we're set for liftoff. The Starlink payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Weather is continuing to look great, and the range has cleared the surrounding ground, water, and airspace, and are also green for launch. For those of you just joining us, what you're seeing on screen right now is a live view of Falcon 9 at Space Launch Complex 40 in Cape Canaveral, Florida. We're just a few minutes away from liftoff. This is the 9th mission for SpaceX in 2021 and the 23rd Starlink mission. this stage, the vehicle should be completing second stage LOX loading.
Stage 2 LOX load complete.
And there's the call out. That is the last of propellant loading for Falcon 9. Continuing to see liquid oxygen being vented from the transport erector lines. This is normal and expected for us at this stage of the countdown.
Ground gas closeouts.
On screen is a view of the fairing. Inside that fairing are the Starlink satellites that we're going to be sending into orbit today.
Falcon 9's in startup.
We are in startup. This means that the first and second stages are beginning to pressurize for launch. In just a few seconds, we should hear the launch director give the final go for launch.
Falcon 9, Starlink LDs go for launch.
And just over 30 seconds, all systems are a go for launch. Let's listen into terminal count and watch as Falcon 9 takes our 60 Starlinks into orbit.
Vehicle is pitching downrange.
Stage 1 chamber pressure is nominal.
Power into telemetry nominal.
We're just under a minute into flight. Falcon 9 has successfully lifted off from pad 40 at Cape Canaveral Air Force Station, carrying our Starlink payloads into orbit. In just a few seconds here, we should be
Vehicle is supersonic.
hitting max Q, or maximum aerodynamic pressure.
Vehicle is now experiencing maximum aerodynamic pressure.
And there's the call up for max Q. In about a minute, we have 3 events happening back to back. First up is main engine cutoff, also known as MECO. This is where all 9 M1D engines shut off to slow the vehicle down in preparation for stage separation.
Chill has begun.
The second event is stage separation. This is where the first and second stage will separate from one another, with the first stage making its way back to Earth for a landing attempt, while the second stage continues its journey with the third event, second engine start 1, also known as SES-1. This is where the single Merlin vacuum engine on the second stage will light up and propel the second stage along with the Starlink satellites into orbit. Again, that is main engine cutoff, followed by stage separation, then second engine start 1. And the first of those events should be happening in about 20 seconds. Both views on screen right now are of the first stage. The left is from the top of the first stage, and the right is a tracking shot from the ground of Falcon 9.
Main engine cutoff.
Stage separation confirmed.
And we had successful main engine cutoff, stage separation, and you can see on the right-hand side of your screen, the engine on the second
Both
stage has
vehicles are
successfully
following
started
nominal
up.
trajectories.
Now we're expecting fairing deploy here in a couple of seconds. We are at T plus 3 minutes and 50 seconds into flight. On screen is a view of the Merlin
Both
vacuum
vehicles
engine.
continue to follow nominal trajectories.
The Merlin vacuum engine on the second stage, glowing red hot. As the second stage heads towards its drop-off orbit, stage 1 will execute 2 burns in order to make its way back to Earth. The first
signal Bermuda.
The first is an entry burn where 3 of the Merlin engines will reignite, and this will help to slow the stage down as it re-enters the upper parts of the atmosphere. The second burn is the landing burn. This is a single engine burn that brings the vehicle speed down rapidly in order to land on the drone ship. We don't currently have views of the first stage right now, but as we approach the landing attempt, hopefully we'll be able to get that view back. The Merlin engines on the first stage are optimized for sea level, and they can achieve 190,000 pounds of thrust during ascent and descent. The Merlin vacuum engine you see on screen is optimized for the vacuum of space,
Both vehicles continue to follow nominal trajectories.
producing over 220,000 pounds of thrust in the vacuum. That first stage entry burn, again, that's the first of 2 burns, should be happening around the T plus 6 minute and 20 second mark, about a minute from now. The Starlink satellites that are on the opposite side of the second stage, we're going to be putting them in low Earth orbit around 550 kilometers in altitude. Most satellites are in geostationary orbit at an altitude of about 36,000 kilometers. When satellites are farther away from Earth, the round-trip data time between the user and satellite, also known as latency, is much higher, resulting in poor performance for activities such as video calls and online gaming. The Starlink satellites, however, operate at over 60 times closer to Earth than traditional satellites, resulting in a much lower latency.
Stage 1 FTS is safe.
And there's the first stage on the left-hand side of your screen.
Stage 1 entry burn startup.
And we have successful stage 1 entry burn start. This burn's going to last for about 20 seconds.
Stage 1 entry burn shutdown.
Stage 1 entry burn has completed. During that entry burn, you might have noticed that
Both vehicles continue to follow nominal
our
trajectories.
4 hypersonic grid fins have deployed near the top of the first stage. The stage 1 uses nothing but these grid fins for steering as it makes its return back to Earth. They orient the rocket during re-entry and guide the rocket during descent. The next milestone for this mission is our landing of the first stage. It's going to be happening in about 40 seconds. Entry burn starting around the T plus 8. During the entry burn, the first stage, landing legs were deployed. We have 4 of them on the Falcon 9 first stage, and they're made up of state-of-the-art carbon fiber aluminum honeycomb. They're placed symmetrically around the base of the rocket and were deployed just prior to landing on our drone ship today.
Stage 1 landing burn startup.
There's a view of our drone ship as Falcon 9 approaches.
Stage 1 landing confirmed.
We didn't quite
Stage
get
2
the
is under
video,
turbo
but we did get
guidance.
confirmation that we did indeed land the first stage. That is the 6th for the, oh, there's the visual. This is the 6th time for this
Stage 2
booster,
FTS is saved.
and the 78th successful recovery of a Falcon 9 first stage. What a way to start off the mission today. Now we're waiting on a second engine cutoff of the second stage, and then shortly after that, we're expecting to hear confirmation of a good orbit.